Hypoxia and Breath Hold Diving by Marty McCafferty, performed by Dr. Frans Cronje. There is an appeal to being able to venture underwater using only a minimum of equipment. The desire to explore unencumbered has led to increasing interest in breath hold diving or apnea diving, which is also called free diving. There are, however, potential hazards associated with this activity that should be reviewed. Understanding the essential components of the human respiratory drive can help reduce the potential for life-threatening or life-ending complications. Human respiration is primarily an autonomic function, requiring no conscious effort. We can exercise control over our breathing, but only for short periods of time. Most of us at some time in our lives have attempted to determine how long we can hold our breath. Regardless of the length of time or circumstances, there's a point at which the urge to breathe is overpowering, and we end the breath hold. With practice and observation, we may have discovered techniques for increasing our breath hold time. One common method is taking multiple breaths in rapid succession just before holding the last inspiration. This is known as hyperventilation. In essence, ventilation that is more than necessary to meet our metabolic needs. Some think that multiple breaths increase the level of oxygen in the blood, but the increase is actually relatively trivial. Except for a few chronic medical conditions, which are typically disqualifying for diving, respiration is driven by an increase in carbon dioxide or CO2 in the blood. The concentration of CO2 in blood is not maintained at the same level as in air, but actually at much higher levels to provide proper acid-base balance. The usual concentration of carbon dioxide is 140 to 160 times greater than that of air. Because of this, hyperventilation can drastically drop blood CO2 levels. The reduced CO2 present at the start of breath hold diving prolongs breath hold time, necessary to accumulate enough CO2 to trigger the urge to breathe. While the urge to breathe is delayed, the slight increase in oxygen content means that oxygen levels can fall too low to maintain consciousness even before there is the urge to breathe. Reduced oxygen is known as hypoxia, and excessive hyperventilation alone is sufficient to cause blackout. When combined with a vertical dive, the decrease in ambient pressure during ascent further hastens the drop in oxygen, increasing the risk of loss of consciousness. This phenomenon is known as hypoxia of ascent, sometimes also called shallow water blackout, because loss of consciousness is likely to occur at the final stage of the ascent. The final stage of the ascent where the decline in relative pressure is greatest, or just upon surfacing, before a freshly inspired oxygen reaches the brain. Taking a maximum of 2 full ventilatory exchanges before breath hold diving is probably a reasonable level of hyperventilation. But great caution is required because hyperventilation works by compromising, although not completely obscuring, our natural protections. Some advocates will claim not to rely on hyperventilation but instead to employ so-called workup breathing or cleansing breaths just before breath hold. These are just different names for hyperventilation, and the same principle should be applied thoughtfully and cautiously. The risk remains, no matter what we call it. Physical activity during breath hold diving will also increase oxygen consumption. Expected safe breath hold times can easily be overestimated. As such, competitive or extreme breath hold diving is a dangerous undertaking. These dives encompass a host of logistical challenges and require rigorous safety planning to conduct properly. Spearfishing and recreational apnea diving are more common, but don't have the same safeguards as the organized events. The buddy system, typically using 1 up, 1 down protocols, can offer some protection for simple shallow activity in good visibility and water conditions with great diligence on the part of the safety diver, but it can easily break down as complexity increases. Dedicated one-on-one supervision is critical, even with swimmers doing laps underwater in a pool. The presence of a lifeguard alone is not sufficient. It is important to remember that close supervision is required even after an apnea diver returns to the surface. This attention should continue for no less than 30 seconds to ensure that delayed impairment of consciousness does not occur. Beyond breath-hold physiology issues, the use of dive flags and floats and selection of dive sites away from boat traffic can also increase safety. Breath-held diving can be safely enjoyed with a minimum of equipment. Manage the risk by seeking proper and professional training before undertaking apnea diving. Many training agencies are dedicated to free diving and its safety. For additional background, download the proceedings of the 2006 Breath-hold Diving Workshop at dan.org.